Hello everyone. In this video, I am going to explain about speed control of a double acting cylinder in a hydraulic system. That means how to control the speed of the double acting cylinder in a hydraulic system. In some applications, we need more speed, or in some application, we need a forward stroke is very less speed and retraction is fast. Say for example, for applying load or for a particular, say for example, in a hydraulic press, we need a more force during cutting operation, and return stroke we need to come back very fast. For that application, we need to control the speed. Like that, we can control either forward or retraction speed by using this circuit. Here, I am going to first explain about the circuit, how it's working. Then I'll explain about how to simulate this same circuit by using AutoSim software. Let me see one by one. See, this is the schematic diagram. Let I explain the working of this speed control circuit. In this circuit, you have a power pack, then 4 by 3 DCV, one pressure gauge and one pressure relief valve, and one check valve, one flow control valve, and one double acting cylinder. These are all the required components to form a circuit. Let me see the working principle. While operating the hydraulic pump with the help of a motor, the hydraulic fluid is entering to the directional control valve through the filter. Here we are using 4 by 3 directional control valve. 3 position, 4 port, ideal position, straight position and cross position. Initially it's in ideal position. Ideal position, there is no flow in the circuit. All the fluid pumped by uh, hydraulic pump will come back to reservoir. The in this direction control valve, there is a port P, port A, port B, and port D. From pump, hydraulic pump, fluid is connected to port P. Say, for example, we are engaging the position 1, that is a straight position. That time, the fluid is flowing position port P to port A, then port A to the flow control valve, and after flow control valve, it will enter the cylinder this side. Also here you have one uh, check valve which will not allow the fluid in forward direction. Only return line only allowed. And the exit of that cylinder is connected to the port B. That will be connected in while engaging the first position till B is connected to T connected to reservoir. This is the circuit. Now you will see here you have a flow control valve. This flow control valve will allow the fluid, quantity of fluid to go to the cylinder. We can limit the fluid by adjusting this flow control valve. That is the main part of in this circuit. Without this, we cannot attain the speed control. By regulating the flow of fluid in this circuit, we can control the speed of the cylinder. Let me see how to do the simulation by using the AutoSim software. First, I will open this uh, Atom sim software. Now we have a hydraulic actuator. For this, I need one double acting cylinder. I'll select that and drag this. Keep this as in this working area. Then we need one 4 by 3 directional control valve. If you want 4 by 3 directional control valve, select that. Or else, if you want 4 by 2 also possible. Whatever you want, you have to select from here and drag it. I'll explain this circuit with 4 by 2. No ideal position. Or else, we want to change this, we can customize this directional control valve by means of double clicking this. Here 4 by 2. So you can change here also 4 by 3. Anything can be possible in this Atom Sim software. So I selected initially 4 by 2 directional control valve, but I want to change the port and the position. So I can modify that into 4 by 3. Here you can select that where it is manually operated, push button or pilot operated, any kind of system you can enable. I am using push button and spring return. Push button with spring return. Or both the sides are push button. Also I want the left side straight position, right side cross position. So I'll select from here straight position, right side cross position. Center position is okay with that. Click OK. Then we need a flow control valve. So select here. Here you have a flow control valve. Select it and drag it. Then we need one check valve. Select it and drag it. I want in vertical position. So select it. Click the right button in mouse. There is a option rotation. Rotate it in 90°. This also in 90°. Okay. Connect this. Okay. So this will be connected to this port. Okay. Now the DCV is connected to hydraulic pump. Hydraulic pump, then a motor, then one pressure gauge, one pressure relief valve. We need one filter, and one reservoir. Another reservoir is connected with the directional control valve. I change this by means of double clicking. Convert this as a filter. Click OK. We connect this filter here. Select it and drag it. We'll connect the reservoir with this filter. We'll connect the pressure relief valve with pump and pressure gauge also with the pump. I want to monitor entry pressure of the pump, and I will connect this pump to DC. That's all. Now we have to check the pressure relief valve pressure and the pump pressure. How much pressure of the fluid is 10 bar. Pump is operating or delivering the fluid at 10 bar pressure. Okay, I'm okay with that. Also, this pressure gauge will open in 6 bar. If delivery pressure of pump is 10 bar, but if it is pressure gauge will open in 6 bar means all the fluid will go directly to the reservoir. At 6 bar only, the supply line or return line pressure will be maintained. Okay, I want to change this 10 bar. Okay, also we have to check the flow control valve, how much flow it will allow. By double clicking this, here percentage of opening is there. So how much percentage of opening you want? You want 100%, 50%, 25%, 70%. How much? Based on that only speed is increasing or decreasing. By if you want a full speed, open it 100%. I'll set 100% initially. Now we will operate this circuit. See here at 10 bar ideal condition, if it is reaches 10 bar, pressure relief valve will open. Automatically fluid will flowing at ideal condition. By means of engaging this straight position, piston is moving forward. If you are leaving this, I want to retract, right? So same speed it's working because 10 bar fluid is 10 bar pressure fluid is going both the side. While operating forward stroke, fluid is entering through this port, going through this way. Here you have a pressure relief valve. See here, it's in opposite direction actually, right? I want to change this position. Rotate 180 degree like this. I will not allow the fluid through this way. Now it's okay. So check once again the circuit. Return stroke is also same speed. Now what I do is I want to reduce the speed of this forward stroke. So I'll set the flow control valve 50%. Okay. So that now we will check how fast the piston is moving. See, piston is moving slowly while retraction is fast. Okay, if you modify the value percentage of opening 20%, now we will see how fast the cylinder speed is. I mean piston speed. It's moving slowly. It's moving slowly. By this way, we can control the speed of the cylinder. It is also called a meter in circuit. That is, the flow control valve is connected in the entry of the cylinder port. If you connect this flow control valve in the exit line, then it is called meter out circuit. That is also possible. If you connect in between these two ports, then it is called bleed off circuit. That is the difference. Okay. By this way, we can control the speed of the double acting cylinder. Thank you.